VAR estimate to be more responsive to the large losses. So if you take lambda appropriately, your VAR will be much better. It will be more responsive to any large losses you have. Okay. Also, what happens is this age-weighted historical simulation will help to reduce the what is known as ghost effect. Okay. What is ghost effect? Ghost effect is, think about it, like in 2004 Indian market, they suddenly tanked by 15%. Right. Now what happened is 2008, right? After that we have not seen that event, right? So what happened, you can say, is that is one dangerous day, one ghost day, which we are not expected to see in the future, right? So what we are saying is it will, so if you model it properly, it will help you to reduce the impact of those events which are not expected to occur in the future. So this is your age-weighted historical simulation. Please note that in the book, author has gone into the advantages of this method as well as the disadvantages of the method. And I have taken some of this directly from the book. So please remember, disadvantages and disadvantages is what you are actually interested in. So if you see the LOS, okay, I have not given the aim statement here. The aim statement, if you see, okay, what they are saying is, okay, describe the following weighted approach. So you have to describe this approach, okay, age weighted approach. Okay, so the benefit is it is generalization of the historical simulation. So what happens is this age weighted is, it's very specific. You can make it a more like a general case where, sorry, historical simulation is more specific, but this age weighted is very much general. If you want to get a historical simulation from this age weighted, you can make your lambda as equal to, so if your lambda changes to 1, if lambda shifts to 1, this becomes 0 or the 0 form. It actually takes the way, it actually takes the historical simulation approach. Okay, so if the lambda is 1, okay, that is a 0 decay. Okay, so this is your decay factor. Okay, 1 minus lambda. So what we are saying is it will take the historical simulation. Okay, so what they are saying is, here the author has mentioned historical simulation is giving the same weightage to all the data. It means as if you are driving the car in a straight road, okay, and it is a straight road and you are seeing the rear view mirror, because you are seeing the history. History is nothing but the rear view mirror. You are seeing the past data. You are seeing whatever you have already covered. Okay, so in a historical simulation approach, all the weightage are assigned the same. You are traveling in a straight road. What if in reality the road is not straight, right? In reality the road is curved. Okay, so your age weighted historical simulation will help you in capturing that curve. Okay, so you would say that try to capture the curve by giving more weightages to the recent, lesser weightage to the past, because once you have passed the curve, okay, you will not be able to see those history, right? So if you see, okay, so if you have this straight road and compare that with a curved road, right? So if your rear view mirror, does this matter? No. What matters is what you are over here. So your curve, your exponentially weighted moving methods, they will be able to capture this kind of things. Okay. Now what they are saying is suitable choice of lambda can be more responsive to large loss observation. A large loss event will receive a higher weightage. So you need to ensure that lambda you are choosing such that your large loss event is getting a higher weightage as compared to the traditional historical simulation. And please note that next day where you will be getting a higher method, higher value. Okay. It helps to reduce the ghost effect. We have seen attraction. What they are saying is you can modify the weighted historical simulation such that the risk estimates are more efficient. Okay, so this can be modified. Okay, so the weighted methods can be modified so that it can be much more efficient, better than the normal method. However, the disadvantage is it is ad hoc. Ad hoc because who decides this lambda? Who decides this sample size? There is no theoretical foundation with respect to what should be this lambda, what should be this sample size. If you see the risk matrix approach, it takes different value. Another matrix can approach take different values. Okay. The next method is volatility weighted. Okay, so volatility weighted historical simulation. Here they are trying to give weightage to the volatility. Okay, this method has been created by Hull and White. Okay, and it is a very good approach as compared to your age weighted. Okay, now what they do in this case, the weightage is done on the return. Okay, but they are weighted by the volatility estimate. So weight the individual observation by the volatility. So what we have over here, think about it. Okay, if let's say you are comparing the past history. Okay, these are your historical data. These are all your historical data. Okay. Okay, we are over here. We want to find out what would be the VAR over here using this historical data. Many returns data are there. Okay, what about, let's say, when these returns data were there, the volatility at that time was low. Okay, and volatility at the recent time has increased. Okay, so since the volatility was low, what happens is these returns would be underestimating the risk. Okay, right? So these returns would underestimate the risk because these returns would not change over day. They would not change by much because the volatility is low. Okay, however, because the volatility in the recent time is more, so this recent change would be much more than what this change we have seen. Correct? So what we say is we try to incorporate the recent volatility estimate. So right, what happens is if recent volatility is more, historical volatility will underestimate the current risk. Current risk as measured by the return. Okay, return would be taken as lower. Okay, absolute number wise. Okay, if recent volatility is less, then historical volatility, these returns would be more and they will overestimate the risk measure. Okay, so one approach is to adjust this by going on the return we are adjusting. So this is the return, it is the historical return. This is the actual historical return that we have seen. We are trying to come up with a new measure of the return, okay, by adjusting for the volatility. This sigma ti, okay, it is the historical volatility, okay, that we have seen, okay, that we have seen in day t. So historical, either you measure by Garch or Arch. Okay, it was a forecast for I done at day t. Okay, and this sigma t, it is the most recent volatility measure. So think about it, what we are doing. Try to see, because I had a tough time understanding this approach. Okay, so let's say we are trying to estimate the VAR over here t, and we are at this point. So today, okay, today end of the day. Okay, so what we are having is, this is the return that I will use RT. Okay, and I want to say, okay, what would be the return that is to be used for computation of the next day values. And then because these are the simulation that are being used, okay, so we have to find out this return so that we can find out the lower values, right? So this RT that I am using, okay, what happens is this is a small day t, so there will be some volatility estimate on this day t, so which is we are saying as the sigma t for a particular asset I. So for a particular asset I, this is the volatility estimate that we have. Okay. What we will do is, we'll say that this return is trying to incorporate this volatility estimate, okay, which is not correct. Okay, and when I want to use this return on this day, I will not use the same return, I will use the star return, I will use a different return. Okay, by trying to estimate what would be the volatility on this day. This is also an estimate of the volatility for an asset I. Let's say we are estimating the volatility is 30%. That day the volatility was estimated to be 20%. Okay, and the return that was that day was, let's say, 2%. Okay, we said that, okay, the return was 2% considering 20% volatility, but actually estimate this day is 30%. So we'll say, okay, the return will not be counted as 2, but it would be counted as 30 by 20 into 2%. So we'll say that the return will get counted as 3%. Okay, this is how you will incorporate either negative, positive, both would be changed. Okay, so this is the return that you will use, and then you will use, so all these past values, okay, will be changed. Okay, all these past values will be changed, and then you will do the sorting of these new returns, and then you will say that bottom 5% whatever you are getting, that will be used. So this is your volatility weighted historical simulation. Okay, it is introduced by Hull and White. Okay, now let us see what are the advantages of this. Okay, what they are saying is it is actually incorporating the volatility in a much natural way. Okay, equal weighted historical does not take volatility into consideration. Age weighted it handles in some arbitrary way. Okay, so this is a much more natural way, seeing the new increase, new volatility, earlier volatility. Okay, this wire estimate that you will get, it will not incorporate the past, but it will incorporate the current market conditions that you are seeing. Okay, so what they are saying is it allows for wire estimates to be higher than the historical data set. So normal historical method will give you some wire. It will help you to get higher or lower depending on the current market situation. Okay, empirically they have tested this method, and they have said that this method indicates that it is better than the approach earlier that we have used, both the age weighted and the historical weighted. So this is like empirically we have found it is better. Okay, now what they are saying is this method can be extended. Please note that this method can be extended to incorporate, let's say, bootstrapping. Okay, now why do I need to take bootstrapping the original return for those days? In fact, I can take the new return, R star return. Okay, so I can take into incorporation. I can also get this R star, and then I can apply this age weighted technique. So there can be various extension possible of this method. So we can combine this with the age weighted, and if we can see that, okay, if you are we can incorporate this age weighted method. So if you want to increase the sensitivity to large losses, or if you want to decrease any ghost effect, you can take this age weighted into incorporation. Again, we do not have to worry about how actual implementation. We need to know the process, we need to know the advantages, disadvantages, etc.